Welcome to the Masons Podcast, your source of insight and innovation in New Zealand building and construction. Each episode explores the products, systems and solutions that support trades, specifiers and developers to deliver high-quality, durable and efficient buildings across Aotearoa, New Zealand. From building envelope performance to flooring, acoustics and fire separation systems, we share practical knowledge and ideas that help shape the built environment.
Hi everyone, welcome back. Today we're looking at a simple but often overlooked part of roof design, and that's passive roof ventilation. It's one of those things you're not likely to notice, but it really does play a big role in keeping your roof space dry and your home healthy. Today we'll break down how it works, why it matters, and what makes Mason's approach unique in helping New Zealand homes manage moisture naturally. Welcome back, Arthur. Great to have you.
Yeah, thanks, Michelle. It's good to be here again.
Now, I'd just like to state in the beginning it would be beneficial to listen to our podcast on condensation in roof spaces, which will explain a lot about why this system is needed. Arthur, can you tell us what is a passive roof ventilation system?
So a passive roof ventilation system is a system that allows for air movement in the roof space, driven by the stack effect, which is where warm air rises and pulls cooler air in, and also by wind movement. So there's no electricity required. It's a natural process and therefore passive.
And why should someone consider using this system?
There is a growing problem in our builds in New Zealand in cold roof design, where with modern long-run roofing, fixings I should say, and flashings, there is much less natural air change. In other words, they're a lot more airtight. What is also a factor is our homes are much better insulated, or buildings much better insulated. We have warmer living spaces. Warm air holds more moisture. That moisture percolates up into the roof spaces, and if it can't escape, it builds up. And as you can imagine, more moisture, more condensation when the dew point is reached, when temperature drops, and a growing number of cases that condensation is excessive and rains down on the timber, the ceiling, and the insulation.
It's a clever system. Exactly what problem is it solving?
What ventilation in the roof spaces is solving is introducing drying through air movement. So if moisture finds its way in, we want moisture to find its way out. And the best way to do that is by providing a passage for air that as it rises and moves through the roof space, it will take moisture-laden air with it. It's just the natural regulation of the air in that space. Look, it's a very, very old idea. Ventilating roof spaces is definitely not new. We used to do it in this country going quite back some time, and sometimes materials and methods were more naturally air leaky, so there was like a natural air change thing. Yes. And then we went away from it, and roof spaces became much more sealed up. This is a general statement. And certainly with modern long-run installations, the guys do a great job of keeping water out, making them watertight, and with that has come much more steps down the road towards airtightness.
Where would most of this moisture come from that gets up into the roof space?
So air anywhere will have moisture content unless you're in the middle of a desert or a humidity-controlled environment. So there's naturally moisture in that atmosphere, but it's added to from the occupied spaces below. So that can be people just breathing and showering and cooking and doing normal things, drying clothes inside. Warmer living quarters, warm air holds more moisture. If it is an industrial environment, there could be activities or procedures that there's more moisture introduced into the atmosphere, and that percolates or trickles up into the roof spaces unless the designer takes steps to stop that.
So this ventilation, it basically stops the roof space from turning into a moisture trap by solving the problem before it starts.
That's exactly what it does.
So how does the moisture content in the air and within the roof space, how does it build up to the degree that it does?
We've touched on how extra moisture loading can get up into the roof space. The key thing there is if there's no path for that moisture-laden air to change or to exit or to be ventilated, then naturally it will just keep building up.
What sort of problems would it create?
Too much moisture in the roof space turns into excessive condensation that's too much for the roof underlay to handle, or for the natural cycle of condensation and reabsorption, which is what's expected in a cold roof in this country. Too much for the systems, the roof assembly and the system to handle, and then we get, the water that's formed in the condensation falling where it shouldn't. That's the fundamental problem we're trying to address.
This is the current situation for some of the listeners out there. What solutions could they consider?
If you have got excessive condensation, now what I mean there is condensation that's so substantial that it's wetting your insulation, falling on your framing timbers, or you may be even noticing stains in your ceiling, that's a problem that needs addressing. So the first thing to do would be to make sure your living spaces are ventilated more than they are now. The second thing to do would be to make sure your ceiling is sealed, air sealed to the extent that is reasonable to do so. There's really good articles put out by brands that people can search for, Google, or go to the brand's website and search for that give you great advice on this. The third thing is, if it's practical to do so or affordable, introduce ventilation into your roof space. Now, at the very least, consider talking to roofers about getting a vent at the ridge assembly installed and a new ridge cap, or maybe the old ridge cap put back on. And if your budget extends to it, or if you're planning a re-roof, then talk to your roofer builder about getting a passive roof ventilation system installed. Now, can I just say, Michelle, I don't want to worry people. A certain amount of condensation appearing in a cold roof design, appearing overnight or in the morning, dissipating later in the day, it's not so much that it's basically wetting stuff around it. That's to be expected. It isn't a problem. It's not broken. It's part of the sort of like roof assembly design and the way things work.
How is the Mason's passive roof ventilation system put together?
The components for our system are ventilated battens. We have 11 mil deep or 18 mil deep. They both have a different amount of ventilation open area or net-free area. There is a spacer that goes down at sort of around the heel of the rafter or the truss, where the wall intersects with the bottom of the trusses or where the rafter sits. The issue there is we want to keep the airflow path open from the eave up into the roof space, and so the air can pass through the ventilated battens. And then there is an assembly at the eave using the ventilated battens and a flashing provided by the roofer or the roll former at the eave. And then at the ridge, there is an assembly of our ventilated battens and special flashing with a soft edge. We suggest that those flashings are colour-coded to the roofing cladding just to make sure that there's no visual impact for people. Those sort of components form the system.
Is part of it the insul baffle, where you have to compress the insulation?
Yeah, so that's the spacer I was talking about. So we call it a spacer. Our particular version is called insul baffle.
Yeah.
But that principle of a spacer, that it sort of just holds the bulk insulation away from the roof, decking, cladding or underlay, and keeps the air gap open.
Provide the required air space.
Yes. Now, in some cases, there may not be bulk insulation there, lofted insulation. It could be a section of PIR board, in which case there may be no need to use a spacer like insul baffle. Okay. So it all depends on the design and what the designer has put together.
And this insul baffle, that provides your required 25 millimetre
minimum
airspace.
Spacing. Yep. From the roof underlay to the bulk insulation.
Great.
Yeah, that's
This insul baffle, can that be used in a skillion roof if you're using a ventilated system?
We don't recommend that, and basically the designers need to consider skillion roofs as a separate matter and give some real thought to the cross-ventilation path there.
When designers or builders are thinking about this passive roof ventilation system, what do they need to consider?
What designers need to think about is the slope of the roof. They need to think about what ratio of ventilation they want. So from around the world, there are various suggestions about the ventilation ratio. So why we talk about the pitch of the roof is we talked earlier about the stack effect. The stack effect is where warm air rises, it pulls cooler air into the bottom, and also wind movement will help power the stack effect as well. With a lower pitch roof, the stack effect is less apparent. So with a lower pitch roof, you need more net free area of your vent. In other words, you need bigger vents, bigger capacity vents. With a steeper pitched roof, the stack effect is more apparent. That's physics. So you do not require such large vents. Your net free area can be smaller. So we have an online calculator that designers can go to. They can put in the pitch of their roof. They can put in whether it's a duo or mono-pitched. There's also guidance on skillion roofs. They put in their pitch, they put in the type of roof, and it will give them the suggested ventilation requirements for our battens to do with the net-free area. And they can also put in the length of the eave and the ridge and the spacings of the rafters or trusses, and it will work out how many battens they need for the job.
So it's not just about throwing a couple of roof vents in, as it is a lot of building science behind it. It's about planning your airflow, sizing your vents correctly, coordinating your insulation and vapour control and accounting for your roof shape and your local climate.
Absolutely. I mean, I take my hat off to building designers. They have so much to think about to get the best result for the client. Durability, buildability, affordability, all the regulations and things they have to work with, standards. We are trying to make the decision around ventilation in the roof spaces easier and more accessible for designers.
Right.
There's been good information out there. There are a couple of other systems around. But to your point, any ventilation in the roof space is better than no ventilation, would be Mason's view. But a properly designed passive roof ventilation system is going to give excellent results. We're trying to cut through that with the calculator online and also the installation manual that we've produced.
And you briefly mentioned the Metal Roofing Manufacturers Code of Practice. What does that have to say about roof ventilation?
We do recommend that the people access the MRM It is free to access, and it has a lot of incredibly good information, including a section about ventilation in roof spaces. It has some really good clear advice, and it also gives suggestions on the right ratios of roof area to the amount of airflow required. So we do recommend people access that as well as the material we provide.
And you mentioned that masons have a calculator to calculate the size of the ventilated battens that you can use.
Yes.
And also how to quantify the amount of battens.
Yes.
So there's an all-in-one tool ready to use at your fingertips. In this tool, it mentions net-free open area. You mentioned that before. What does that mean?
Basically referring to the ability of the ventilated batten, what we're constructing at the eave or the ridge, to pass air through.
Yeah.
So NFA, net-free area, or net-free vent area, there's various terms. They all mean the same thing. It's the ability of the ventilated product to pass air through.
Okay, so it's the actual open space in the vent or the batten.
That is correct.
Yeah, okay. Masons mention that skillion roofs require approximately double the ventilation to a trussed roof. Why is this?
There's a much reduced air gap in a skillion roof. There's not a lot of air volume. The gap is small. They are susceptible to moisture forming inside there where you won't see it. And it's well recognised and well understood that skillion roofs require the maximum ventilation that basically you can get in there without spoiling your overall design or look or thickness of your skillion roof. So they need at least 1 to 150 as a ratio in terms of ventilation. And people could do more if they want to, if they can make that work with their overall aesthetic and their barges and their gutters and all the rest of it.
Due to their restricted air movement in that small cavity.
They're susceptible to condensation forming inside there, or sweating. If people want to have the old term, they're subject to sweating, and you can have terrible problems in there if that's not dealt with at the start with good design.
What about the underlay? Does the designer have to specify a mason's underlay with your passive roof ventilation system?
We always encourage people to use the mason's products together, but no, it's not strictly necessary. Any brands approved or code mark certified underlay would be fine. If people have a favourite underlay they like to call up or to use, no problem.
And is the roof ventilation system guaranteed to eliminate excess condensation?
Guarantee's a strong word. I would say that if it's correctly sized, correctly installed, it will substantially remove condensation in that roof. Like very substantially. There will be no excessive condensation. And that's what we're concerned about. We're concerned about water forming and dropping down onto other elements or getting into other building elements and causing problems. With a properly sized and installed passive roof ventilation system, you will have minimal condensation. You possibly may have no condensation, but certainly minimal.
Okay, so it really is a key player in reducing your condensation in the roof space by significantly reducing the risk of heavy condensation.
Yes, and long-run roofs. It's strongly recommended for modern, long-run aluminium or steel roofs.
Let's talk about cost.
Yeah.
How much is it going to increase the cost of your roof system to put one of these ventilation
Yeah, it all comes back to this, doesn't
systems
it?
in? Yeah.
Yeah. So depending on the batten thickness that's chosen and depending on the type of installation, because you've got product at the eave to provide an eave intake vent, you've obviously got the ventilated battens to provide the air path, and you have got an assembly at the ridge. Talking to some of the roofers who are using it, the additional cost on top of the normal cost of installing that roof from where to go, around $20 to $30, $35 a square metre. A lot of people land on around about the $25 a square metre more as of this time. So it's just a broad guide. we do encourage people to get their quotations from their roofers because there's quite a bit of extra labour and to get things right and to get things lined up and everything good. But it's one of these things, it's an investment at the beginning of the building's life. And in terms of ensuring durability, in terms of ensuring good performance from the insulation and the ceiling, longevity of everything up there and that roof structure, it's just to be firmly recommended.
And it is passive, so
there's no energy required once it's installed.
When installing the system and it's exposed to the weather, you put the battens on, how quickly should the components of the system be covered by the roofing?
We require a maximum exposure to UV of 21 days in a roofing situation. As everybody in the roofing industry does, we recommend same-day cover. Same day, next day is best practice, and everybody pretty much tries to get things covered same day.
Generally, that happens anyway,
doesn't it?
Yes, it
just generally does, yep.
Yeah, okay. Let's talk about loading on the ventilation battens. Snow, wind, you have crush loads from fixing it and also people walking on it.
Absolutely. So those things have all been tested for and checked. Our battens are very strong. They're very resilient to crush loading, trafficking. In terms of snow load and wind loads, there is no issues. They're more than up to the challenge.
So they can carry your normal construction loads and light foot traffic.
Yes.
Is there anything else that our listeners out there should know about the Mason's passive ventilation system?
It's a straightforward system. It's something that your roofer and your roll former supplier can easily put together for you and install for you. There are some considerations with the height of the fascia or barge and positioning of the gutter. Also, we do recommend with the flashings that we call for in our version of the system, at the eave and at the ridge, we suggest that they're colour-coded to the roof cladding colour to take away any visual impact. Where people are looking up under the ridge cap, they don't want to see a black line. Yeah, so those are some things to think about. You will need longer fixings. So one of the extra costs is that people will need to specify or fit much longer fixings because you've got to go through the thickness of the batten, or sometimes 2 battens, before you get into your framing. So that's a consideration.
Okay.
Designers definitely need to consider the site as well as the slope of the roof and the roof type. What I mean there is that if you've got an extremely windy site, or if you've got a site that's subject to gusting from time to time, you don't want too much wind being driven through there.
No.
Sometimes people will put a baffle in there using, say, a redway cavity closer or something. It does throttle back the airflow substantially, but you're trying to prevent the problems of the wind being driven with too much force through that. It's not a biggie. It's just something that some designers will need to think about.
So can you tell us what else people might need to know about the Mason's passive ventilation system?
Perhaps key limitations. Don't expose them for more than 21 days in a roof setting. Same-day cover is better. If they're going to be traffic, that is people walking on them, they need to be fixed off with screws or nails at intervals to restrain them properly. You'll find the information in our manual. They're for use in roofs design up to and including extra high wind zone. Above that, talk to your structural engineer. If you've got Euro tray or similar special wide tray European style product, check with the manufacturer of that product. It's quite possible these may not be suitable, as they often have specialised clip systems or specialised support systems to, make sure they go together well. Look, apart from that, these battens are pretty much non-reactive with pretty much everything. They are easy for the guys to install once they've planned for it and got all the components on site. To get the best results out of any system, and including this one, it should be properly sized, and including the eave vent and the ridge vents, the whole thing, and the placement of the underlay, cutting the underlay at the ridge or making sure the underlay isn't installed so that it closes off the eaves vent or the ridge vent is critical to get the result you want. So it's a combination of good design and good installation, and then the homeowner or building occupant will never have to think about it again.
Fabulous.
That's what we want.
Is there any final things that you can mention that people can do to try and keep condensation to an absolute minimum or to eliminate it in their roof space?
At the risk of repeating ourselves, the first thing people should always do, designers, builders or occupants, make sure your living spaces are properly ventilated. If you have built a really modern home with a good degree of airtightness, consider using a mechanical heat recovery ventilation system. So you're not wasting the energy you put in to warm your living spaces, and you're getting constant fresh air brought in and exhausted, moisture-laden air taken out. That's honestly, I would recommend that for pretty much any new build if your budget stretches. You don't have to be a passive house or a high energy efficient home to use one, although they are in those as well. The next thing is make sure the ceiling is sealed. If your building is in a new build, it's not difficult to get a vapor barrier in there. Perhaps choose a product like PIR board with aluminium facings for your ceiling insulation. So you're going to get a vapor blocker and an amazing insulation layer. So you get a 2-in-1. Make sure your access hatch is airtight, so you're keeping moisture out of the roof space. And thirdly, introduce ventilation. However you do it, introduce some ventilation into your long-run metal roofing cold roofs. I beg you to do it. As I say, any ventilation is better than no ventilation, but a well-sized passive ventilation roof system, your customers, the homeowners, the building occupants, you'll never regret it.
Thanks, Arthur. So to briefly summarise, the Mason's passive roof ventilation lets warm, moist air escape naturally. It protects your roof, your insulation, and your timber structures from condensation.
It assists with that.
It's simple, it's low maintenance, and New Zealand compliant, and it's a really smart way to keep your roof space dry and your home healthy. And I believe there's a full set of drawings on Mason's website showing the various methods of application. And of course, if anyone has any further queries, you can contact Masons direct or via their website, mpb.co.nz. This brings us to the end of our podcast. We hope you enjoyed this session, and we look forward to meeting you again at our next informative podcast. And thank you again, Arthur, for your time.
Thanks, everybody, for listening. Thanks for listening to the Masons podcast. We hope you've gained some practical insights and ideas for your next project. Be sure to subscribe so you never miss an episode, and visit us at mpb.co.nz for more information on our product, systems and solutions. And join us next time as we continue to explore smarter ways and solutions for building in New Zealand.
This podcast is for general information only. While we aim to provide accurate details on building products and systems, Masons is not liable for reliance on this content. Always follow product specifications, manufacturer's instructions, and relevant building codes.